Before we start building out our fracture to look a lot better, I'd like to actually get the physics set up on this so this acts like a physics object. So if we change this from selected viewport up here to simulate, and then we start our simulation, if it hasn't already started, we can look at some of these cubes that come with a default level, and when we drag them up, they'll fall back down because physics are enabled on them. And we can see it's not working on our cube. And so in order to have this work, we need to have this set up as a geometry collection, which is how Chaos, the Unreal Physics engine, will read this to be a chaos object and how it will have destructible physics on it. So let's take a look inside of Houdini. We're going to need to set up a couple of Unreal specific attributes on it, which we can actually find here. If you go to sidefx.com and go to chaos integration, this is a lot of documentation on, let's scale this to the right size, on how to write attributes that Unreal will read for our chaos system to understand. So there's a lot of attributes here. We have Unreal GC piece, cluster, and we'll go through all of these as we get to them. But basically, this is how we can control a bunch of things like the mass of our object, which pieces are clustered together, how hard it is to break them apart, optimization stuff like what type of collision it should have. So yeah, there's just a ton of stuff here. And also a really great example resource for us to look at if you're interested in. So this is an example HDA that they have in their documentation. And if you want to find it, the location for it, as well as some other good example files, is going to be within our plugins folder here. There's a Houdini Engine folder, and inside of that, there's a content, and then examples, and then chaos. And there's a lot of really good examples in here, and even some other good HDAs that you could look at for miscellaneous things. So the chaos one is one of these three, I believe, and you can just install the HDA into your project. But yeah, let's go ahead and get this set up. So to start, I'd like to get some clustering on our cube. And we can do this with an RBD cluster. If we just plug this in like so, and put an RBD exploded view after it, we can look at what it's doing now. So you can see that the exploded view is now a bit different because some of our pieces are hanging out together, and these will read as one object or as stronger objects to hold together inside of Unreal Engine. So like if you were to shoot the cube and have it break, this piece right here would be a lot stronger and you'd have to shoot it like 2 or 3 times to break, while these pieces would fall off really quickly. And so we can change the size of our clustering. We can change the detach amount. And really, there's a lot of customization. We'll probably want to up this to a parameter at some point. But for now, let's just keep our size at 1 and our detach ratio at like 0.1 as well. So we get a few random stray pieces here. Okay. And so with this, after we're clustering it, I'd like to create another subnetwork for this to keep things organized. And this will be how we initialize our Unreal attributes. So I'll just say initialize Unreal Physics. Okay, and in here to start, I'd like to put down an attribute wrangle. I'm not sure why it's red. Oh, I need to stop our performance monitor. Yeah. Okay, I've accidentally created a light. Oh, goodness. There we go. All right, I've deleted the light. I'll scooch this back over. Okay. So with our attribute wrangle, we just want to write something out like this. We just want to say I at Unreal _GC for geometry collection _piece equals 1. And this is going to initialize this attribute. And this should be a primitive attribute. And so if we come back to our documentation here, so it's just specifying the primitive as a geometry collection piece. And if it were set to 0, it would not be part of the geometry collection. So we're just going to initialize every single piece for right now to be a geometry collection piece. And then we're going to want to use a attribute copy to create a copy of our current name attribute to work off of. So we'll take our name attribute and we'll give it a new name, which is GC name. And from here, we'll actually want to put our RBD cluster after this. So I'll just Control X and plug it in here. Because what's going to happen is if we don't make a copy of our name right now, the RBD cluster actually updates our name. As you can see here, it's changing it to be part of a different cluster, whereas before it's just a piece. And so we just want a copy of it so that we have the original name to work off of down the line. Okay, and so with this, we'll put on another attribute wrangle, and we're going to want to set our geometry collection clustering level. So if we look back over here at GZ cluster, this is the index, so it's which group to group the pieces to, right? So I'll put down another RBD exploded view. And plug our cluster in. Yeah, so each of these big clusters here is going to need their own Unreal GC cluster name here. So I'll copy and paste this. And we can write out something like this. You'll see that our RBD cluster is creating negative numbers too, and those should be from detached pieces. If we disable it, there's no negative pieces. And so we want to keep those detached pieces detached. So we'll only work on pieces above 0. So if we say something like, I'll delete this for now. We'll run this over primitives, and we can say if I at GC cluster, or I at cluster, is greater than or equal to 0, then we'll open our brackets, and we can just say I at Unreal GC piece ++, which will mean it'll just add to itself. Let me make sure I'm spelling everything right. Unreal GC piece. Oh, this needs to be a primitive attribute. That's why it's creating a new one here. Yeah, okay, so now we can see our clustered attributes, or our clustered pieces, will have a Unreal GC piece value of 2, which will mean they'll be on the second level. They'll be considered parented underneath the main object inside of Unreal. And this will make a bit more sense once we visualize it in Unreal, so just hold tight for a little bit longer while we set up some more attributes. And then we can just do one more thing here. We can say I at Unreal GC cluster equals I at cluster. And so now we have our same cluster attribute that Unreal will read and recognize now. And this is the not so fun part. So if we put down one more attribute wrangle, this is where we're going to go ahead and initialize all of our physics attributes for it. So I'm going to do something where I'm just going to copy and paste it over from here to here. And there's a lot of different attributes here that I've set up, and I would recommend y'all to copy and paste these, but we can read through these and understand them a bit better. So I'll set this up a bit more. I'll create these cluster strengths here and set these to like 10,000, 50,000, and maybe 20,000. We'll just give some random numbers for now. another 50,000. And if we see any issues in Unreal, we'll fix it. And I'll set our mask to like 1,000 to start. I think that's the default Unreal mask too. Okay, so all I've done here is initialize some attributes to have some control over if we want to promote them to HDA level parameters. But what's happening is we have a lot of attributes here, like the Unreal GC clustering damage threshold. So for each level of our clustering, we can control how much damage it takes to destroy it. So I've just set that up to be controllable here through cluster 1, 2, 3, and 4. The collision type, as you can see, I've commented out here. We have a 0 or a 1 value, and this should all be in the documentation too. And we want to set this up as implicit rather than particle implicit, because if it's particle implicit, it's a lot cheaper, but it's not very accurate. The collision type I've set to, it should actually be 5 for convex. But I do think this feature isn't working right now, so we can just ignore it. But I'd like to set this up to be a convex collision when we import it. Level set resolution isn't too important. It's just optimization stuff. Reduction percentage is just how much smaller the collision is than the original mesh. Mass as density is just a default object or default parameter that we want on. Here's our mass, which we definitely want control over. And these aren't too important. Yeah, we do want it to notify breaks because we'll use that later down the line for Niagara. But this should all be set up now. So I'll just rename this to like Unreal Attributes. All right, so we're just about done with this. We've created all of our attributes. These do need to be primitive attributes. It's a good thing I caught that. And I'll just plug this in like so. And the final thing we need to do is just pack everything up. And we want to pack this using our GC name. We'll disable our exploded view. Maybe I'll keep it on actually. So if we just pack things like as is and check on our name attribute, we're getting 27 packed fragments right now. And that is going to mean that Unreal is going to read this as 27 objects that can't be broken down any further. So this is why we created the GC name attribute, so that it uses the unedited name version before we clustered it together. So we can just say GC name. And now if we look at this, we have 200 packed fragments. And Unreal also wants these to be not packed fragments, but rather just packed geometries. Packed fragments, I think, are better for RBD simulations. But I think this should all be set up now for Unreal to recognize. So let's cross our fingers and test it out. I will save our project, save our node type, go to Unreal, and rebuild all instances. Houdini session stopped. Oh, because I'm simulating right now. I need to stop simulating and rebuild this. And if it works, we should see in our outliner here. Great. So it's created a child object to it, which is actually our geometry collection. So this is working exactly how we'd expect it to so far. We're going to need to head over to our cube before we do too much more. I did do this beforehand, but we need to type in hidden and make sure that our original cube is hidden in game. And then we need to disable collision on it as well. So if we just type in collision, we change our collision preset from default to no collision so that it doesn't interact with our geometry collection on start. So I'll save our Unreal real quick. And if we simulate, let's see what happens. Cool. So our collision, our actor is physicalized, which is great, but it's not too exciting. You can see if we kind of slam a cube into it, it looks like it's working, but obviously the collisions are a little bit jank looking. But overall, a pretty cool result so far. I did also re-update our actor to have 200 fracture pieces. Here. Somewhere around here. Oh, that's on this one. Yeah, I set this to 200. So let's look at our geometry collection now. If we go from selection mode to fracture mode, this is kind of where all the magic is happening. And we can see the results of our setup. So if we increase our explode amount here, Unreal has a built-in explode amount for it, which is great. You can see this is our original cube that we do need to hide in our outliner. And we have multiple fracture levels to it now. So we have fracture level 0, which is just the entire object. Fracture level 1, which is going to be our clustering, which looks like it's too big. Our clustering is too big because this is all one cluster with a couple detached pieces. So we'll have to adjust that. And then level 2 is going to be everything. It's going to be all of our pieces. And so if we come back to all levels here and look at our fracture hierarchy, you can see because we set up our Unreal GC piece, we are starting to have pieces parented under other pieces. And it's not really a lot, unfortunately. We have our main cluster here, and then we have these are our random detaches, sorry. And then these are our random, or our clustered pieces. So let's just tweak our cluster values before moving forward in Unreal. I'd like to promote it to a parameter. So I will go into our initialized Unreal Physics, look at our cluster here, and with the type properties open, we will just add in a couple values. We can say our detach ratio and our size are probably fine. And we'll create a new folder for this called clustering. And this should be a simple folder. We can just drag these two in there and name this from like size to cluster size, and detach ratio should be fine. All right, let's save our node type again and come back to Unreal and re-import and rebuild it. All right, so we're looking at our HDA still, and let's adjust our cluster attribute. So the size, I will lock it here. And let's try something like 2. And we might have to go lower to 0.5, but let's see. So let's go from fracture level all to level 1. Yeah, okay, so I think we have to go to 0.5. Let it think. Still too big, apparently. What about 0.2? All right, still not working. That is interesting. I'm going to try 0.1, and if not, I'm going to go ahead and debug a bit and get back to y'all once I figure it out. Okay, so I figured out what the issue was. I set our cluster size back to 1, and turns out it was a typo. Just a classic Houdini Unreal maneuver. So the only issue was this was missing an S, so it was CLUTER instead of CLUSTER. So there we go. I'll resave our node type and re-import it into Unreal, and we'll have a working version now. Okay, so now if we click on this and increase our explode amount, we can see our clustering is working. We have multiple levels here, and it's parenting them as you would expect here. So if we go to all levels, yeah, you can start to select entire clusters now. So let's go ahead and set our explode amount back to 0 and tweak the physics a little bit before calling this a good episode. First thing we want to do is set up the collision type. So if we go to our outliner here, click on our geometry collection and go to the rest collection here, there's a lot of attributes we can adjust in here. So it should bring up this window for us. And you can see a couple of settings that we've already set. Like the mass here was set inside of Houdini to be 1,000. So if we change that parameter, it would actually update here when we rebuilt it. What I would like to change though, the big one is this implicit type here. It needs to be from box to convex. And it's a little unfortunate that this isn't working, but I will reach out to Side Effects and request for them to get this, I think it's a bug, fixed. Maybe I'm doing something wrong, but it used to be working. So if we set this to convex, it should act a lot more accurate now. And let's give it a test. Okay, so far so good. If we run a cube into it, let's see what happens. Okay, it hasn't broken yet. But yeah, you can see if we like smash it hard enough, we'll get pieces to break off. So it's pretty fun to play around with, actually. We'll do that one more time. Why not? Move this over, give it a bit of a bonk. Maybe hit it with this one. Yeah, and so you can see our clustering is working because this is a lot stronger than the rest of the pieces that broke off. Cool. So we've got this all set up. Let's go ahead and call this good for this episode before moving back into the art side a little bit for our Destruction HDA. I'll see y'all there.